This assessment asks us to rank the following aldehydes and ketones in terms of the reactivity with nucleophiles. So we're imagining a nucleophile attacking any one of these four carbonyls, which means we're ranking them on the basis of how electrophilic they are. Right? To start with, we can identify what type of carbonyl they are. So we have an aldehyde here on the left, two ketones in the middle, and then another aldehyde on the right. Because aldehydes have less hyperconjugation, less electron density being donated to the carbonyl carbon, aldehydes are going to be better electrophiles. They're going to react more quickly with nucleophiles. And so our aldehydes are going to be 1 or 2, right? They're going to be the two that are most reactive. And the ketones will be 3 and 4. Now let's decide which is which. Well, if I redraw, I'm going to redraw this aldehyde here on the left so that we can look at the influence of the 3 fluorine atoms. Now we know that fluorine is incredibly electronegative, the most electronegative atom, pulls electron density away 3 times. That's going to generate a pretty big partial positive charge there. Having this big partial positive right next door to the carbonyl carbon is going to make that carbonyl even more electrophilic. It's going to be even more reactive with nucleophiles. As a result, this aldehyde here will be the most reactive molecule. The other aldehyde, because aldehydes are more reactive than ketones when reacting with nucleophiles, this one will be number 2. We only have hydrogens and an alkyl group attached at this alpha carbon, so we're not getting the same inductive effect that we had happening here. Next, let's look at the ketones. The thing we want to notice is the difference. The difference is that this ketone here has nothing at this alpha hydrogen, or at this alpha carbon, whereas this alpha carbon has 3 methyl groups, or 2 extra methyl groups. We have 3 methyl groups there. Now, those methyl groups aren't going to have a big electronic effect, not going to have a big electronic effect on the carbonyl, but they will have a big steric effect. So any nucleophile that was trying to get to this ketone is going to be interrupted sterically, right? It's going to be blocked by those 3 methyl groups. As a result of that steric hindrance slowing down the nucleophilic attack, this one is going to be the least reactive, making this one number 3. This is the ranking of the 4 carbonyls as electrophiles, or how quickly they will react with a nucleophile.